Okay, before we get started, I am going to cover 5.1 today, but I do want to talk, I thought I was going to do 5.1 and 5.2, but I don't want to do 5.2 until next week. So we're just going to wrap up this week with 5.1. So you'll do this week will be the Chapter 3 review, the Chapter 3 test, and this section 5.1 that we are about to do. I've already changed the due dates in Math Lab and put the things in the correct folders. So everything should be where it needs to be. So only Chapter 3 review, Chapter 3 test, and 5.1 is due this week. We'll do 5.2 next week. Okay, before we get it, where this section is talking about exponents and exponent rules. When you have a number that has an exponent, this number right here, that is called your base. That is your base number. This little number up here is called your exponent. What the exponent tells you is how many times you need to multiply the base number together. So this exponent tells me if I want to do 6, this is called to the third power. That means the same thing as multiplying 6 together 3 times, which would mean 6 times 6 times 6, which if you do that in your calculator gives you 216. So again, when you have a number that has an exponent, the base number is the main number, the exponent is the little number up in the right. The exponent tells you how many times to multiply this base number together. So I multiplied the base number together, which is 6, this many times. So let's look at number 1. You've got 3 to the 5th power is how that is read. It's going to ask you what the base is, what the exponent is, and then it's going to say, well, what is 3 to the 5th power equal to? So in this representation, which one is your base? The main number, 3, is your base. The exponent is that 5. So what does that tell me? That tells me I need to multiply this base number together 5 times. So 3 times 3 times 3 times 3 times 3. So 3 multiplied together this amount of times. So you can do that in your calculator, just 3 times 3 times 3 times 3 times 3. Or you do have an exponent situation in your calculator. 3 to the 5th power. So go ahead and type in your base, 3. See this little up arrow? Watch what it does when I push it. If I push the little up arrow, look what it does. It moves my cursor, my little box, up into the exponent area. Then I put in whatever my exponent is, which is 5. Now be careful. You don't want to keep typing up there, because if you do, you're going to keep adding things up to that exponent, and you don't want to. So to get out of your exponent, just hit this right arrow key. Hit enter. 3 to the 5th power is 243, which is what you get if you multiply 3 times 3 times 3 times 3 times 3. You get 243. Number 2, negative 4 to the 5th power. And it has the negative 4 in parentheses for a good reason. Base, exponent, and then what is negative 4 to the 5th power? So which one of these numbers is your base? the -4. The exponent is 5. So that would mean what? You multiply -4 together 5 times. So again, -4 together 5 different times, or in your calculator. Whenever you're typing a number, I should have done it even with the 3, but especially every single time, if you are typing a negative number and then raising that negative number to an exponent, there has to be parentheses around that negative number. So again, open parentheses. Now remember, the negative button is not the minus button. Remember, they're separate. This is the negative below the 3. So -4, close. So put your base in the parentheses. Now remember, how to get up into the exponent is this up arrow. And my exponent is 5. And then get out of your exponent. So -4 to the 5th, hit enter, you get -1024. Now, there's 2 exponent rules that we're going to go over today. One called the product rule and one called the power rule. The product rules of exponent. When you are multiplying the same bases, you add their exponents to simplify it. So for instance, on number 3, it says 6 to the 5th times 6 to the 9th. Remember what your bases are. I have the same bases. I can simplify this by putting my bases together and adding their exponents. So 5 plus 9 gives me 6 to the 14th power. Now, I could type in what is 6 to the 14th, but on this particular problem, it states write your answer in exponential notation, which means it wants the exponent answer, not what you get when you type 6 to the 14th in your calculator. It wants the actual exponent answer, because the main objective of this problem is for you to be able to show that you know that 6 to the 5th times 6 to the 9th is simplified by writing that same base and then adding their exponents together. Okay? Same thing on number 4. Another thing that goes along with this rule. -3 to the 7th times -3 to the 2nd. Do I have the same basis? I do, which means I can write this as -3 and then add their exponents together. So 7 plus 2, or in other words, -3 to the 9th power. -3 to the 7th times -3 to the 2nd is the same thing as -3 to the 9th. Right? Number 5, same thing. B to the 4th times B the 9th times b to the 4th. Are all those bases the same? Yeah, they're all b. They're not just regular numbers like our other ones were, but they are the same base. They're all b's, which means this is the same thing. I can simplify this by writing its same base and then adding those three exponents together. So that's the same thing as saying b to the, let's see, 13 plus 4 gives me 17. So b to the 17th. Same bases, add exponents. One more of these. I've got -2 x to the 7th times 5 x to the 8th. So we're still multiplying. This rule only goes for exponents. So where is my same base situation here? This x and this x are same bases. I'm still multiplying. I'm still doing -2 times 5, which gives me -10. I just don't need to write these x's in two separate spots because they're the same bases, which means I can write them together by adding their exponents to get x to the 15th. So again, multiply what's in front of them, -2 times 5 to get -10. Since you're multiplying same bases, right? X to the 7th times x to the 8th, I can add those exponents to get x to the 15th. The power rule, which is the other rule that we're going to talk about today. The power rule of exponents says when you raise a base, to more than one exponent, you multiply the exponents together. So again, anytime you raise a base to more than one exponent, you multiply the exponents together. For it, what that would look like is if you have x to the 2nd and then again to the 5th. So see, what's the base? The base is x. It's being raised to 2 exponents. You simplify that. That is the same thing as x to the 10th. You multiply those exponents together. So on number 7, you have 2 to the 4th, and then again to the 2nd. 2 to the 4th power, and then again to the 2nd. So what is the 2 being raised to? The 2 is being raised to the 4th power, and again to the 2nd power. So is the 2 being raised to more than one exponent? Yeah, it's being raised to 2 different exponents, which means I will rewrite this with my base is 2. Now multiply those exponents together, and 4 times 2 gives me 8. So 2 to the 8th power. Now in your thing, you'll notice that number 8 is marked out. We're not doing that one. And again, this one, it wants you to write your answer in MATLAB in exponential form. It wants to see the base and the exponent. It doesn't want you to punch 2 to the 8th power into your calculator. It wants to see those, it wants to see that exponent and the base. So leave it just like that. All right, number 9, use the power rule for exponents to simplify the expression. And this one's multiple choice. So what does this parentheses mean? That parentheses means that every single one of these bases is being raised to the 5th power. It also looks like, so these right here, when you don't see an exponent over something, it automatically means that it's being raised to the 1st power. So all of these bases in here, 3 separate bases, they're all being raised to the 1st power, which means when I multiply these bases together, I have 8 is my first base. Multiply your exponents. What do you get when you multiply 1 times 5? 5. Move on to the next base. What is it being raised to? It's being raised to the 1 and 5. So when you multiply those exponents together, you get x to the 5th. And what about the y? What is the y being raised to? It's being raised to the 1st power and the 5th power. So when I multiply those exponents together, I get y to the 5th. So everybody in there is being raised to the 5th power. And the last one, number 10. If you have a fraction in parentheses, with an exponent outside, that means every single person, every single part of what's inside this parentheses is being raised to that exponent, which means what all is being raised to this 6th power? The 5 is being raised to the 6th, and so is the 2 is also being raised to the 6th power. So that's as far as I want you to take. It wants you to take it again. It wants to see in this problem that you know if you have a fraction in parentheses, both parts of that fraction are going to have that exponent, the top and the bottom. All right, so again, I will see y'all on Tuesday because I will not be live on Thursday, since I'm at that conference.